Thank you, Sandeep. Good morning, everyone. Hope the coffee not only is taken, but also active and in effect at this moment. We're going to touch among a few topics. One thing about the model. We are not here to discuss among us. Feel free to chime in with questions, with experiences, with disagreement. This is something that we like. Okay, so anytime. Yep. Thank you very much. Okay, yeah. So this is going to be the format of the model. Good morning, first. I would like to... Here we are discussing at hardwear.io about hardware security. But the question is for everyone, what is hardware? What do you call hardware? I mean, in my experience, I've seen so many people calling hardware different things. I mean, if you work in an IT security company, then you have the PCs, and then it is hardware. Then if you work in you're looking at the Android security, then there is, at least from a normal perspective, from a user perspective, yeah, there is the OS, and then there is hardware. And then you look at the router, and it is hardware, which has maybe even 100 lines of a code. So what is hardware for you? And for you?
Hardware is the base of everything that we do into this industry. But we cannot forget that hardware will never work without software. And really the border between hardware and software is becoming more and more gray. I work in firmware for a long period of time, and firmware is becoming more and more intercorrelated with hardware. And what is the real boundary? I don't know any longer.
I think it's very hard to separate nowadays hardware and software layers, because these abstraction layers is really deeply integrated even in the silicon level, right? So basically, I would say probably going to deep to the logical gates, it's a hardware layer, everything what we abstract and create in terms of optimization or kind of instruction level or micro instruction, whatever it is of software. And I remember when I joined at Intel, I kind of was thinking assembly is a low-level programming language, but I've been so wrong.
Example, SMM.
Yes.
Hardware or software.
Yeah, very clear ideas. For me, hardware is gates, silicon, and whatever is on top, I would call then software. But from my understanding in the industry, I generally call hardware. I realize that people call hardware what they don't control or they don't understand. It's one of the two, basically. So if it's in a black box, then it becomes hardware. It can be at any level, include anything. But apart from this introduction, we are going to touch about firmware security first, and supply chain, and also touching also on how we can, what are the risks, what are the attacks here, and the mitigation, but of course, what is the proper way of growing and in order to improve security from the side. And we're also talking about technology, also about confidential computing, among the others, because we think it's a topic that may be relevant for everyone. But let's start from firmware security, and of course, Alex is a king in the field with his own research and so on. How would it look like a firmware security in respect of cloud? Because in the end, this is what we're discussing. It's an overlapping is a boundary which has not been explored yet. Firmware, hardware, and cloud.
I think for cloud it's even more important, because if the attacker can compromise the firmware and persist on the server, it's not like exposing the single client. It can expose hundreds of the clients, and this is very critical. And I would say finally actually disclosed over a year 300 plus vulnerabilities, and basically this is a repeatable failure. It's happening a lot. We're talking about UEFI ecosystem, and we'll be talking about the supply chain where actually you discover a problem. One vendor is fixed, but few others it's don't, and it's take kind of for years, even for known problems. And I would say finding vulnerabilities for the firmware, it's not that complicated because we don't have much mitigations implemented in place. And these bugs are kind of like repeatable because also static analysis software which exists, it's not really focused on the firmware. It's not suitable to finding these classes of the bugs, and it's missing a lot. So I would say it's kind of like a complex problem, and I see a lot of positive movements in the industry. People try to think more about proactive ways how they can identify the bugs, but also I would say we don't have kind of like a dedicated knowledge base about the firmware vulnerabilities, and product security teams, I think, were struggling about like how they can mitigate it effectively if they have just one variant of the bug, right? So this is a huge problem. What do you think, Stefano?
Yeah, for sure, the identification of bug in firmware is a completely different ballgame in respect to finding bug in software. One thing that I would like to touch on what were you saying, that security is extremely important for cloud service provider because the infrastructure that the cloud service provider are giving us is affecting our life every day. But I also want to indicate that a real infrastructure security will not come only from the security of the server, but also on the client, because remember that every one of us is accessing the services through their client, and this can become a very easy way to enter into the infrastructure and damage the same. But how the ecosystem has answered to the identification of security problem in firmware is very exciting. Remember that firmware has always been that part of software that was enabling the hardware to boot, the hardware to work. So in the firmware community, there has always been the approach to positive testing, but negative testing, especially in the last 10 years, I could say, have become a very important part of our validation. And thanks to people like Alex and Binary, we have made, I think, a lot of progress. I could say that we have started about looking at real mitigation into the firmware probably about 10 years ago. And while in 2015 we were filing something like 10 advisory per year to our customer. Now, just in the first 6 months of this year, we have filed almost 100 new advisory for our customers.
Very good. I would like to add also panelist, not only the so I will add also my view on this. I think that the main challenge at this moment is that I do see in the SOC security in the industry mostly discussed as a CPU security problem. Well, in the end, actually, our root of trust, our computing trust, is related, or usually as a boundary usually related to the SOC, to the system on chip, which is not only the CPU. So, in my view, the firmware which we need to consider, needs to face a more system level problem. Let me give you a very quick example. So, in most devices, for example, when we are using, let's say, a warm boot, okay, you need to save the context of this boot for the next reboot in order to ensure that you have a sane execution. So these context pointers are saved somewhere because the DDR cannot be used because it's in self-refreshing, okay? So in some solution, these contexts are stored in the always-on domain in the power controllers. There is SRAM. We push stuff there. Now, of course, you verify at cold boot, and everything is trusted. Then you before going to sleep, you put all this stuff there. Now, if you actually compromise the power controller in order to modify this context from when you actually boot up, you're going to have a compromised main CPU. Okay? Now, this is something that you cannot solve only by thinking at the CPU. You need to consider also other components at the system level. So I think that the challenge that will wait for us, and we already see actually in ARM-based and SOC-based in devices, in ARM-based SOCs and so on, the challenge we're going to have is more composition, as yesterday Rodrigo was mentioning, where system A is good, system B is good, put them together, and you get something which is completely broken, and they're still good, respectively. So I think the challenge here that we're going to have is going to have to face complexity. And not my fear, not even my concern, I'm aware that most of the discussion at this moment is mostly firmware and CPU related, which is fine, but probably we need to grow in a more holistic view at the system level. At least that's my stance. And I'm glad to hear that there are solutions thinking also about this, right, Stefano?
Yeah, absolutely. What you're talking about composition is very important because, for example, firmware provide a number of services to the operating system in order to interact with but what we have seen is that in reality these services can be misused, and a big part of our work has been to protect these interfaces, these APIs, in order to be able to provide the right services to the operating system, but avoiding that a rogue agent may use the same in order to unravel the platform. What I'm talking here is about SMM, that besides the CPU, has been one of the major area of investigation of the research community in terms of identifying security problem into firm. I'm sure that Alex has a lot to say.
Alex, no, by the way, on this topic, maybe it would be nice to know how has the industry received your research. So when you actually talk about this problem and...
Yeah, I think also connecting the topic to cloud computing. So basically, we need to think about the attacker model different on the servers, on the clients. Sure. And I think in many cases, when you find SMM bug and reporting to the vendor, if this bug not persistent, vendor say, oh, it's disappeared after reboot. But how frequently do you reboot the server? Not very much, right? So it's still persistent for a month, for a week, but it's persistent, which can be very dangerous. Another thing, we recently did research on some ARM servers, and we realized actually NVRAM on ARM is very different for UEFI. Actually, the variables persist for reboot. That means you can survive reboot until the hard reset, which is actually give different attacker perspective on such vulnerabilities. And basically, we don't have the right attacker models from the vendor's perspective. Another interesting problem I faced, we recently disclosed 60 vulnerabilities with physical access to one vendor, and vendors say it is security problems, but it disappeared after reboot, required physical access, even if it gives you code execution and system management mode. It's not that problematic as we can see. We say to the vendor, can we actually post this to public tomorrow? And the vendor say, oh no, wait a minute, it's still a security problem. And I think this is really a problem about the definition of security boundaries, attacker models, for different types of computing we have in the industry.
Yeah, on this, and I have a question for you, Stefano. I would like to add that in terms of attacker threat model, there are many attacks that I think are possible, but I'm not sure they're considered. Think about Plunderbolt, for example. So doing fault injection in a way that is, we call it software activated. So where software can trigger fault injection attack in order to attack software. So it's software triggering hardware vulnerabilities for exploiting software. Well, Rowhammer is one example. Plunderbolt is another one. There was also one using a clock and the voltage on a Qualcomm processor. So all these kind of things actually move the range of hardware attacks outside of the range of physical presence. Because in our head, in our mind, usually hardware attacks require physical presence. This is not true anymore. Now, so the question is that, are we also thinking about this threat model, all these kind of things? Or are we just thinking of still along the lines of what we usually do, rather than what we are starting to know, which is a bit something different? Stefano, are we considering this kind of attacks, for example?
Yeah, absolutely. With the increased complexity of the SOCs, there are a number of new possible attacks that are becoming a reality. And these that once were considered corner cases are becoming now more and more relevant. So obviously this has increased the validation period of the platform, because you need to increase your validation plan with the verification of many different use cases in respect to what we were using in the past.
On this side, apart from identifying the threat, when you actually receive a firmware vulnerability notification and so on, you prepare also the patches. How easy is to push this to the ecosystem? Because this is actually a real supply chain in the end. Because attackers may attack through the supply chain, but also fixes needs to go through the supply chain, and seems to be some resistance there. I think
you have touched the most, the biggest topic that we have on our plate today, and obviously with the proliferation of the number of platforms. It is once that you identify a vulnerability, to propagate the mitigation throughout the supply chain is a very big challenge. We inform our customers as soon as we have a mitigation available, and we publish both information directly to our customer through our communication channel. We also publish public information. There is really a big trade-off that we need to play here, because obviously we want to be all transparent, right? We want to provide as much information as possible in terms of ensuring the security of all the system that we are using. But we have a trade-off because exactly of the supply chain, because we know how slow it is, the propagation of this mitigation. Putting information public without a reasonable embark date really could cause a lot of systems that are present in the field that have not been mitigated by the supplier. They become at risk. So we need to be sensible to what is the reality of the world out there, of how much the supply chain is able to apply this mitigation. And from this point of view, a big effort that we are currently doing is to create a system and method in order to facilitate the propagation of this mitigation into the ecosystem, to verify that these mitigation have been applied, providing both white box testing and black box testing, so that we can. It is possible for the manufacturer to have all the information that they need in order to apply the mitigation and to verify that this mitigation has been applied. I'm sure that Alex has a lot to say about the supply chain.
Yeah, it's my favorite topic. Basically, I would say specifically for unified ecosystem, supply chain is very complicated. We have like a silicon vendors and their reference code on top. We have like a ecosystem code related to independent device developers, and we have so many different OEMs, ODMs, and suppliers and device manufacturers. So basically, this is complicated the ecosystem so much, and all these layers of supply chain, they keep failed separate, right? So, and in the same time, like let's say silicon vendor release a fix, and IPv kind of like a slowdown to apply this fix, then it's not comes to the vendor, but once it's known, it's published on silicon vendor website, and basically it's kind of can be discovered, rediscovered, or understand by the attackers. And I would say really ecosystem-related vulnerabilities, it takes years actually to fix and develop. By many reasons, and I can give you one very interesting example. I don't want to blame the vendor, but we reported a bug and to vendor X, and this vendor actually didn't tell us the bug is related to reference code from one of the silicon vendors. And then, basically, after the disclosure, like, this became public, and silicon vendor came to us and said, why you not report to us directly? But like, how we know it is related to the reference code? In the end, it is impact entire ecosystem on one vendor fixed, and like hundreds of others don't. This is create kind of like a very complicated situation when it's very opaque ecosystem, and it's playing negative role specifically from the supply chain perspective.
And don't forget the open source component that there is into the
open SSL version is firmware. It's crazy. It's like every developer of third-party component there use open and unify, and like we found in some of the vendors like for 9 different versions, and the best being Infinia. They used like an 8 years outdated OpenSSL version, and they related to firmware security. So it's been used in TPM update Dixie driver, which is getting more crazy, right?
Yeah, and for us, obviously, as an IPv, is a very sensible topic because, again, we cannot force our customer to update their project. I mean, it's not. We are supplier of the manufacturer, so all that we can do is provide information on how to mitigate. But because we have clearly seen that this has not worked well in the past few years, now we have also become a CNA, so we also publish ourselves CVEs. Because, I mean, at the end, we need to find a way in order to move the supply chain in becoming, again, it's a big trade-off. We need to be very sensible about what type of information we provide directly to our customer and what we put into the open. But yes, it is surely one of the most big problems that we have in front of us.
Yeah, I think congratulations to becoming the CNA is an important step, but I would say also like what we faced in the supply chain when basically the same block can have multiple CVs from different manufacturers or like device vendors when it's related to ecosystem block and silicon vendor, and it's been not reported to silicon vendor, reported separately to different device vendors. And this is very complicated, obfuscate actually the mitigation or like fix at scale of this vulnerability. And I really basically think from the perspective of like a race condition, when we have all these layers of supply chain, every layer can fail separately, and it's kind of creating the race condition of the supply chain. And also some of the bugs actually can be fixed multiple times. I think, James, very similar with this situation, not in firmware, but on operating system layer. Same things happening in the firmware. And to be honest, like if you think about unified firmware nowadays, it's like a 6 million plus of code lines. It is an entire real-time operating system below the main host operating system. It's very complex, and kind of like for modern client computing and servers, we grow firmware for 30-something years from 8 kilobytes to hundreds of megabytes on modern servers. This is quite crazy and also requires way more attention, creating more focus on the hacker models and knowledge base about vulnerabilities. Most of the product security teams which is focused on the firmware, they learning from the operating system bugs. In many cases, they are irrelevant or don't provide enough context to actually focus on firmware-specific problems.
I would like to extend this challenge not only to firmware, but in general to the digital industry. I do work a lot with devices, as you know, guys. When we buy a device, when we take the final product, the usual attribution of the responsibility perceived by the final user who should be maintaining the security of the device is that brand which is printed on that guy, right? That's the perception. But in reality, let's say it's not common understanding or common knowledge, at least, that, for example, the iPhone X had components from 200 different suppliers, 200 between software and hardware. Now, it's difficult to say, hey, you have a bug in your stuff, you need to fix it. Of course, even if you want to say, hey, we are going to provide patches for the next X years, you can actually do that only for your subsystem, for your component, right? It's difficult unless there is an industry level understanding and common agreement to have this kind of promises defined of the end devices, right? Now, I think that the reflection that we're having here needs to be also extended at the idea of digital products that we create. I mean, they are very rare, the situation where one party can claim even, I would say, more than 70% of the final device. Extremely. So maybe this discussion probably is not so much on the complexity only, but maybe on the lack of having a framework between different parts of the industry that allow even at least to talk, or even to say, hey, I don't provide patches, but at least you need to say it, because it should be something that should be known in terms of risk assessment in the end. And even also the perception of the user that maybe the user, I'm not talking about the final user that buys a commercial device only, but the final user of the service of the digital system and so on, to have the tools for assessing what is better and what is worse in terms of security maintenance. Does it make sense what I'm saying? Feel free to chime in with anything that you would like to add, of course, even from the audience.
It made completely sense, this proposition, because again, a firmware of the laptop that you have there has so many components inside it, and it is very. At the end, it is the brand that is responsible for the end work, but it is also necessary for the end user that make use of that device to understand at least in having the big picture of this composition. And it's for this reason that we have sponsored at the UEFI forum level the creation of a new working group about SBOM, because even the executive order of the White House 14028 that require SBOM for software is not really still applicable to firmware, because firmware has not been identified, I don't know why, as a critical element of the critical component of the IT ecosystem.
It's that thing that stays there, right?
But again, what we have done is to sponsor this working group for SBOM that practically provide more transparency, provide the information to the end user about what are the components that are present into the firmware of the system that we use, and in order to understand where there could be a need of mitigation, because only knowing the recipe will allow you to know, okay, this open source component has been updated, this other driver from the silicon vendor has been updated. So we need some standardization, and only in pushing this forward we will be able to provide to the community the necessary element in order to identify and judge between different products that are existing on the market.
Anyone having strong feelings? Anyone having strong feelings against or in favor of S-bombs? Speak out.
How many S-bombs you've seen for sure? So basically, S-bomb is my favorite topic to talk about. So first of all, it perfectly works for open source code bases, but in reality, we don't have everything open source, right? So, and when you get S-bomb and binary blob, how we can really validate these bits and match together, right? So basically, like, we are creating now supply chain of S-bombs, and basically, we try to solve supply chain problem with S-bomb, but at the same time, we're talking a lot about the policy side of this movement, but not many tooling and actual validation and visibility on the binary code level is being done. I think it's really problematic and need to be more focused from the community about like how we really make this thing sorted out, because the vendor give you binary blob and S-bomb. Does this really match? The version can be basically similar, but the components can be not really updated in this S-bomb format, or someone fails on the intermediate level. But also it's kind of like a recursive problem, right? The vendor who actually give you binary have the same dependencies on their side, and does their S-bombs match or not? And it goes a lot of layers down. So I would say we really will be facing the problem when validation of S-bomb will be way more important than S-bomb generation.
It's a good point. And in terms of this complexity that we are now touching upon, one of the most favorite tools nowadays from vendor side, at least for either vulnerability identification or bug bounties. So many parties have bug bounties. What do you think? Do you think that this tool is appropriate, should be the only one for investigating such complexity? What kind of even feedback you get? What is the noise to signal to noise ratio and all these things? What also do you think? We have a few, by the way, here.
It's two sides of bug bounties, right? So it depends on the goal of researcher. If researcher wants to fix the problem, probably bug bounty not the best way, because when you give bug and get the money, so after that, vendor controls the timeline and you can't really enforce anything. Now it's not your bug anymore. So if, and I have like some of the bugs disclosed like 2 years ago and it's still unfixed, but we get the bound. So I think it's kind of like shows how the problem at scale with bug bounties work. And I'm talking about the firmware, maybe other layers of ecosystem, it works perfectly with bug bounties. But I really believe from benefit for ecosystem and fixing the problem, it's actually decline the bounty and define more strict 90 days or like more realistic disclosures. Sometimes for the firmware it takes longer, but sometimes the fix is just like 5-10 lines of the code for get variable bugs, for example, and it takes 12 months to fix. This is sometimes kind of like surprised me very much why it takes so long, a while when you basically need just to write 3 lines of code or 5 lines of code. So I mean, and if you go through the bug bounty, it can stay forever, because basically, usually how vendors define on the firmware side when they give you a bounty, they say, we're not assigning the CVE, we're not give you a timeline, you take the money, and when we decide to fix, you get a notification. I don't think it's actually help ecosystem to recover from the bugs.
Bug bounty is a a topic that would require a complete session to discuss about it. I think that a lot is really depending on how these bug bounty are managed by the organization that make use of them. For sure, it is a way to recognize the effort that has been put by some researcher into, but it will never be a full compensation of the effort that has been put into it. And I would say that also another important point that typically bug bounty is a single point of failure, but as we were discussing before, often the problem are related to composition, and really, yes, solving a single point of failure is the start of a solution, but it is only the start, meaning that there may be many other similar issues that are coming in place. So it is very important to provide pattern analysis. That is something on which we have worked with Binary very effectively on this example of the variable that Alex was indicating. So it is just one tool. Mm-hmm. It is just one tool that is part of the toolbox that we need to employ in order to really sanitize the ecosystem.
Yeah, no, I fully agree. I also think that's one of the challenges here is also being able to design the bug bounties in order to explore the different attack surface. Because if the only attack surface which is immediately available to the end user is actually the really the external one, it will take quite some time to reach the inner layer in order to get explored. So the question is that, are we exploring the different security boundaries in a proper way, basically? So that's why initiatives also are being seen in publicly, of course, in public, like of invited researcher, which are being given more access, more tools in order to explore a different security boundary, more internal. And also think that collaborations between, let's say, different entities and partnering between, let's say, researcher and vendors, I think that would be an effective tool for exploring even more, even deeper, in a more effective way. What do you think, guys?
That is absolutely correct. And in effect, let me say that CERT has done recently a very important step to collaboration, because they have created a program called VINS that allow for collaborative vulnerability disclosure. We are participating into it. Alex and his company are participating too. Is a much more is a very efficient way in order to identify what are all the individuals into the supply chain that are affected by a specific vulnerability, and also are an effective way in order to understand the ramification that this problem have, and really is also improving in somewhat the concept of measuring. Because currently, as a measure of the vulnerability, we use a system that it is CVSS score that I have some doubt about it. It's been thought very carefully for the software world, but I have my concern about how it is used into the firmware, because the type of problem that we encounter in firmware are very different from the problem that are encountered into the software world. So the measure that CVSS bring into the importance of a vulnerability is not sometimes very well described by the CVSS score. What do you think, Alex?
Related to CVSS score, we definitely need more like a domain definition and kind of like a scope, which is CVSS score for specific areas. But I want to comment about Vince's activity from the Carnegie Mellon cert. I think it's actually very interesting when you can have an independent arbiter for like ecosystem-related bugs, but at the same time, it can get in the weird loops when 200 vendors in the discussion, and then suddenly one vendor came and say, "Oh, wait a minute, it's a week before the disclosure, and we didn't read this report. Can we delay for like 80 more days?" And this is happening frequently. I don't know why, but I think the idea is very actually right for fixing ecosystem-related bugs, because when it comes to one vendor, it takes a lot of time to coordinate, right? And usually vendors not very happy about that, because for their third teams, it's a lot of work and basically a lot of time focused not on their product. I think it really need to be kind of like independent arbiter, like a Carnegie Mellon cert or whatever other cert, which can help to disclose these vulnerabilities to researchers, help to coordinate vendors' fixes, and actually it can help with supply chain and the entire ecosystem to be aligned on the problems which need to be fixed. But come back to CVE scoring and others, we're facing a lot of discussions with multiple vendors when even for the same bug, different vendors can score differently. And we basically try to create the framework, which is we share with the vendors to show why we make the decision about this CVE set scoring is relevant for this particular vulnerability class. And this helps, but I think we need to create this framework publicly available for everybody and use as research community to actually get more connected and aligned with the vendors. Another interesting thing it is in many cases when researcher came to the vendor like kind of not very happy about the bugs, right? But in the same time, vendor actually get free security assessment and researcher helping to fix the problems. I think he deserved to be kind of like treated more in the way of like he helping the company and not like he bringing the problems. We will be fixed someday, but it's not important for us now. I mean, this is kind of like not really ethical, but happening a lot of times, unfortunately.
Okay, before closing, one thing very short. I think that CVSS is completely unsuitable for our hardware bugs. If you're talking about hardware bugs, not only it's not used in the hardware security industry for measuring the impact of bugs and how difficult it is to find, and there is one specific reason that in order to confirm bugs in hardware, I'm talking real hardware logic, basically, there is no other way, especially if you're talking about fault injection, than actually reproducing that. You cannot look in code and see that there is a vulnerability here. So recognizing the bug implies that you need to find it again. And that's basically how you confirm the bug. So that's why this is the main reason why that CVSS is completely useless for hardware security and so on. But, I mean, really a flash comment, because, I mean, we have been talking about many things on confidential computing before closing. Your thoughts? 2 sentences. Thank you.
Confidential computing is the future. We all work with CSPs provided platforms, but at the end, what it is running on this platform is our information that need to be protected. So confidential computing has been in the industry let me say a goal that has been tackled already for many years. We are on the path, but we are not there yet. And in order to have real confidential computing, I strongly believe that we need to have more secure platforms that are secure from the hardware level point of view, making sure that every time that the platform is booted is making use of authentic and secure firmware, because at the end, confidential computing is depending on the firmware running on the platform to be completely secure, because it is at the end the firmware that is enable all these hardware features that make possible confidential computing.
Yeah, for me, confidential computing is like SBOM. It exists only on the paper, nobody's seen it. So, hardware is not yet there. So basically, I think we're working in the right direction, but actually a lot of work needs to be done to make confidential computing happen. And yesterday, Rodrigo keynote actually shows all this speculative execution and all this domain of the problems that actually breaks confidential and impact confidential computing badly. Before we fix all these foundational problems, it's no confidential computing, basically.
On this, I would like to say that basically I fully agree with what you just said. There is a bit of a difference between the device world instead and the system we are talking about in this moment. And the reason is that secure boot is already a cornerstone since, I would say, at least 1 decade in some digital devices like mobile phones. And that cornerstone must be there. If it's not there, I mean, the rest on top actually crumbles down. And I'm not sure that in the industry and in the cloud security and in platforms and in firmware and UEFI, we are there already. While for other devices, I think the situation is slightly different. And that boils down to the fact that in devices, the owner of the root of trust is identified and known and recognized as such. While in the PC industry, that has never been the case because of the open design of PC since the inception.
You have opened another ocean.
No, we don't have time for that, unfortunately.
Identity of hardware is one of my favorite topics.
I would say, let's continue the discussion outside, if you like. I mean, we are all open to keep the discussion in right after the panel during the day. I mean, but let's keep in touch. Let's keep in discussing. Thank you very much. I hope you enjoyed, and let's continue to have a great day at hardwear.io. Thank you.
Thank you.